Let's briefly look at the kinetic molecular theory, which defines the properties of ideal gases. So there are 6 postulates we are going to talk about, and here's number 1. Gases are composed of a large number of particles that behave like hard spherical objects in a state of constant random motion. This means we represent gas particles as spheres. So they're hard spherical objects and they're constantly moving in an unpredictable pattern. Postulate 2. These gas particles will move in a straight line until they collide with another particle or with the walls of the container. And you should have seen this when you were playing around with the simulation. The gas particles always traveled in a straight line like this. I'm moving the cursor back and forth until they hit another particle or the container walls. Postulate 3. Gas particles are much smaller than the distance between them. In other words, gas particles are incredibly small and there are massive amounts of space in between each gas particle. That means that most of the volume of a gas is just empty space. Number 4, there is no force of attraction between gas particles or between the particles and the walls of the container. Gas particles typically do not have charges. That means they won't repel or attract each other, and they won't be attracted to or repelled from the walls of the container. Postulate 5. Collisions between gas particles or with the walls of the container are perfectly elastic. That simply means that the energy the gas has when it collides with another particle or with the walls of the container, it will continue on, it will bounce back off with the same amount of energy. So no energy will be lost when the gas particle collides with the walls of the container or with another gas particle. And finally, postulate number 6, the average kinetic energy of a gas particle depends only on the temperature of the gas. It depends on nothing else. The energy that a gas contains is dependent only on the temperature of that gas. If we increase the temperature of the gas, we will increase the energy those gas particles have. And if we decrease the temperature, we will be decreasing the energy of the particles. So here are the 6 postulates all together on the same slide, and you should have been able to observe at least 3 of these when you were playing around with the simulation, and I hope you did. Let's do a quick check, so just pause this video and answer true or false for each question. All right, here are your answers. You should have gotten true for each of these 3 questions, so I hope you got a 100% on this quick check. Thank you all for watching.